Hi, I'm Paul. We're doing Leetcode Must Know interview questions. Today's challenge is Game of Life. We've been doing matrix challenges. I think this is the last one in the matrix challenge category, but I don't remember what's next. Anyway, here's what we need to do. According to Wikipedia's article, the game of life, also known simply as life, is a cellular automaton devised by the British mathematician John Horton Conway in 1970. This is a kind of interesting if you see it, in a graphical implementation, which we're not going to do. But anyway, the board is made up of an M by N grid of cells, where each cell has an initial state, live, represented by a 1, or dead, represented by a 0. Each cell interacts with its 8 neighbors. So, you can think of the cell as being the center of a 3 by 3 square, and it has 8 surrounding neighbors, horizontal, vertical, diagonal. And the game has the following 4 rules. Any live cell with fewer than 2 neighbors dies. It's lonely. 2, any live cell with 2 or 3 live neighbors lives on to the next generation. 3, any live cell with more than 3 live neighbors dies. Overpopulation. And 4, any dead cell with exactly 3 live neighbors becomes a live cell, like reproduction. The next state is created by applying the above rules simultaneously to every cell in the current state. Births and deaths occur simultaneously. Given the current state of the board, return the next state. Okay, and they have some examples here. Let's see. I don't know. Do we need to go through the examples? Nothing happens here. 1, that changes to a 0 because there's not enough neighbors. Nothing happens here. This one it's dead, but it has 3 neighbors, so it comes back to life. This one is lonely and it dies. This one also comes back to life because it has 3 neighbors. It doesn't seem to be an overpopulation situation killing anybody here. Anyway, could you solve it in place? I hadn't thought about that, but I have a feeling that any in-place solution is kind of playing loose with the definition of in place. My definition of in place is that you're not allocating any additional storage. You're not allocating matrices or arrays or hash maps or anything. In place. Now, as it says here, the board needs to be updated simultaneously. You can't update some cells and use their updated values to update other cells. Well, that's the problem with doing it in place, is you can't really do it simultaneously. You have to simulate some kind of simultaneity, but how do you do that without, stepping on your, yourself? So I don't know. I can't think of a way to do it in place, but that doesn't mean there isn't a way to do it. We're not going to do it. In this question, we represent the board using a 2D array. In principle, the board is infinite, which would cause problems when the active area encroaches upon the border of the array. How would you address these problems? Well, again, we're not going to do this. We're not asked to do this, but you could add some code to implement kind of a wraparound effect where the left and right columns are adjacent. They function as though they're adjacent, and the top and bottom row function as though they're adjacent. So you could do that. But anyway, yeah, we're not gonna do that. Let's say a couple more things before we write the code. One is we are going to allocate an additional matrix to hold the future state. We're going to loop through every cell in the input board and count how many neighbors does it have. I'll say more about that when we code it. But yeah, we're going to count how many neighbors it has, and then we're going to implement the rules. Not enough neighbors, too many neighbors, just the right amount of neighbors, or it's dead, but it has 3 neighbors, so it comes back to life. And I think that's about it. So let's start with this. Int, oh, you know what? We can't start with that. Well, actually, let's start with this then. Int m, I don't know what to call it, m, let's call it length equals board dot length. Int width equals board 0 dot width. All right, now another matrix. Int future equals new int length width. Okay, now we can do the loop. I'm gonna give myself some more coding space here. Okay. So let's start looping through it for, oh, wait a minute, wait. No, that's okay, we can do it. We can just start looping it for int I equals 0, I less than length I plus plus, for int j equals 0, j less than width j plus plus. Okay, we need a variable to hold the neighbor count. Int neighbors, initially 0. And then count the neighbors. All right, so we've got a cell. We've got a value for I and j, and we've got a cell, and we need to count the 8 surrounding neighbors. Well, there's more than one way to do that. You can have like a transition table where you keep integers from -1 to 1, and so we're in the center cell. What if we want to look at the top row? Okay, so subtract 1 from the column, subtract 1 from the row. And then leave the column alone, subtract 1 from the row, and then add 1 to the column, subtract 1 from the row, and so on. We're going to do a more primitive approach. We're just going to imagine the current cell as the center cell of a 3 by 3 matrix and write a nested loop to process the 9 cells. I'm going to process the 9 cells. Now the center cell, we don't want to process that in our neighbor count. So after we do the neighbor count, we're going to subtract out the current cell. Where'd my cursor go? Oh, there it is. Yeah, I need a new line. Let's tab out there. All right. Nested loop. I need more index names. Let's just call it I. It's gonna start at -1. It's gonna go from -1 to 1, both the row and the column, and that's gonna allow us to process all the cells in the 3 by 3 matrix relative to the current cell. So I equals -1, I is going to be less than or equal to 1, I increment, let's do this, okay, let me copy that. This is going to be J, 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 J. All right. Now what? Well, I think I'm missing a bracket here. I'll put it in. But okay. One more thing we got to do here is if a cell is on the edge of the board, if it's in the top row or the bottom row or the left column or the right column, it's not going to have 8 neighbors. And if we try to access 8 neighbors, we're going to get an index out of range. So before we access a neighbor, we've got to make sure that the index that we're trying to access is actually on the board. So we need an if statement for that. We'll say if, I can put this in parentheses. Well, what's the best way to do this? Yeah, that's probably good. We'll say if I plus I is greater than or equal to 0. It's got to be greater than or equal to 0. And it's got to be less than blank. I need another parenthesis there. All right. Actually, I don't need that. I don't need the parentheses there. We can just leave it like that, and then say, and it's going to be pretty similar. Let me just copy this. J plus J, J greater than or equal to 0, and J plus J, J is less than width. All right, good. So the index is on the board. Both indices are on the board. And then if that's true, then we can say neighbors plus equals board and use those indices, which would be I plus I and J plus JJ. All right. Close the if there. Whoops. Close the if. Close the for. And I gotta remember to subtract out minus equals board I, J. All right. Now we can implement the rules. Right? Yeah, now we can implement the rules for the cell. So let's say if board, I made parentheses here, board I, J, if it's alive and neighbors is less than 2, it's going to get lonely. And it's going to die. No, future. This will be in future. Future I, J equals 0. All right. Next one is going to be similar. else if the board is alive, if the cell is alive, but the neighbors are greater than 3, the cell dies. If the cell is not alive, but the neighbor count is exactly 3, then the cell comes back to life. And the only other possibility is that nothing happens at all. It stays the same. All right. I think that's it. What have we got here? All right, we've got a loop. It goes through every cell. It counts the number of neighbors. Based on the number of neighbors, it updates the future state. But we gotta copy the future state back into the board because this doesn't actually return anything. It expects to get the next state in the board. So what I would like to do is just do something like board equals future. But I don't think that's going to work. I don't think you can copy matrices that way. So let's do it like this. We'll just copy it. We'll copy it row by row. For int I equals 0, I less than future dot length I plus plus board I equals arrays dot copy of future I. I'm not sure if I have to put a length here, but I know it'll work if I do put a length. So I'm going to put a length. All right. Let's try it. I don't know. Okay, let's try it. That looks like it turned green. No, compile error. Int width, board 0 width. That's not what I meant to say. Okay. Board 0 width. No. Board 0 length. All right. Try it again. Accepted. All right. Basic cases. Good. Let's frame. Open this up a little bit. Submit. All right. Well, it looks like everybody had pretty fast solutions for this. I mean, like 80% used something that rounds to 0. So if you used 1 millisecond, you're too slow. All right. So that's it. Game of life. I think that's all the matrix questions. That the next challenge is some new topic. So feel free to like, subscribe, and see you next time.